Now when we draw a circuit, we need some simplified notation, because drawing a nice picture of a battery and a light bulb and a switch gets very difficult very quickly. So we have symbols for things. For example, a battery is symbolized by a long straight line and a short straight line parallel to it. The long straight line represents the positive terminal, the short straight line represents the negative terminal. A wire is simply represented by a straight line. A light bulb is generally represented by a circle with a little looped wire inside it. That represents the filament of the light bulb. And the other important thing is a switch. A switch is a place where we can break the circuit or re-establish the circuit. Remember, current will only flow if I've got a nice continuous loop all the way around. If I flip this switch up, there's no continuous loop. I might get a little bit of positive charge on one end, a little bit of negative charge on the other, but it'll be very slight and the current will very quickly stop flowing. A couple of other things here. If we happen to want a double switch with two different positions, it would look like this. A single switch that has two different positions looks like this. Okay. Now we're also, so if I want to draw this case of a battery with a light bulb and a switch, I could draw this drawing here that actually looks something like what it would look like on the table, but this drawing is simpler to draw, simpler to see what's happening. It's got a battery represented by a long line and a short line. It's got a few wires connecting it to the light bulb, another wire connecting it from the light bulb to the switch, and then from the switch back to the battery. So you should try and become proficient at reading circuit diagrams and being able to recognize what they mean in terms of actual wiring. Now we also want to be able to measure current and voltage. An ammeter measures amps. It's what we use to measure current. Notice there's no P in an ammeter. A voltmeter is used to measure voltage, or the voltage drop across a circuit element. Ammeter is written as a circle with an A inside it. Voltmeter is written as a circle with a V inside it. And here we have three ammeters joined together with two light bulbs. So we've got the current coming out through the first ammeter, through the light bulb, through the second ammeter, through the second light bulb, through the third ammeter, and back to the battery. And all three ammeters are measuring the same current. So even though we've got two light bulbs in here, it's not using up current. These are old analog style voltmeter or ammeters. Most modern ammeters and voltmeters will look something like this. It's a digital multimeter. Multimeter means it can measure many different things. This one's set to measure ohms. You'll plug wires into these receptacles here at the bottom. You will always have a wire in the common. By tradition it's black, but there's no reason it needs to be. Your other wire is traditionally red, but doesn't need to be, and it'll plug in here if you're going to use it to measure voltage or resistance, which we'll talk about in a minute. You'll plug it in one of these if you're going to use it to measure current. Generally start with it in this 10 amp side. Now, how do we want to wire it in for each of those devices? Well, let's look back at our waterfall analogy. If I want to know the height of the waterfall, I need to make a measurement before and after the waterfall. Which means if I need to know the voltage or energy change per unit charge, I need to measure both before and after the circuit element. So a voltmeter always goes in parallel with the thing we're trying to measure. Okay? Parallel, we look to get the same height. When we have two things in parallel, they have the same voltage drop. So this will have the same voltage drop as the light bulb. Now an ammeter is different. If I wanted to measure the current going through this, I would want to get something that let me collect all the current flowing in one side, measure it, and then let it go back out while affecting the situation as little as possible. So that means we need to have it in series so that the current flowing through the ammeter matches the current flowing through the light bulb. Now you may have noticed a little bit of current is going to flow through this voltmeter, which means this ammeter will have a little bit more current than the light bulb. That's pretty unavoidable. The only thing we can do is try and make it so as little current as possible needs to go through the voltmeter. We could also get rid of this connection and connect the voltmeter over here. Then the ammeter would only be measuring the current through the light bulb, but the voltmeter would be measuring the voltage drop across both the light bulb and the ammeter. So it'd still be getting some error. And to eliminate that error, or to minimize that error, we would try and make it so that the ammeter had as small of a voltage drop as possible.